Okay, in this video, I am going to show you how to determine what the end behavior is of different polynomials. So the first one we're going to look at here is f of x equals x cubed plus 3x squared minus x minus 3. So the most important part to find the end behavior is to look at what we call the leading coefficient or the leading term. So my leading term here is always the term that has the highest exponent. So in this case, that is going to be my x cubed. So in other words, my exponent, which is considered the n, is 3. So we look at this, and now we know that my end behavior is going to be in the odd category. So that means they're going to be the opposite of each other, my ends. In the evens, the ends are always the same. But we want odd ones, we want the ends to be different. The next thing I need to look at is what is my leading coefficient? Is it positive or negative? As you can see here, we can't really tell what the leading coefficient is because there's nothing there, so that just means that it's the number 1. Okay, so since our leading coefficient is 1, this means it is positive. So my end behavior is going to be fall from the negative and rises in the positive. So in other words, just to sum up what we did, as x goes to negative infinity, my y goes to negative infinity. And as x goes to positive infinity, my y goes to positive infinity. So let's look at another example here. Let's look at f of x equals x to the 4th power minus 4x squared. Again, we want to look at the leading term, so we can do the leading coefficient test to find our end behavior. So in this case, it's x to the 4, which means my n is equal to 4, which is even. Again, my leading coefficient is just 1, which is positive. So this means my end behavior are both up. So in other words, as x goes to negative infinity, my y goes to positive infinity. Woo. Okay, and then as my x, sorry about that, x, let's be clear here, goes to positive infinity, my y goes to positive infinity as well, and you're going to have sort of a W-type looking graphs where both ends go up. Let's look at one more type, okay? What if we have f of x equals negative 4x cubed times x minus 1 times x plus 5? So my negative 4x cubed is important, but it is not my leading coefficient because it's only one of the factors. So if you think about this, this x is considered 1, and this x is also considered to the exponent of 1. So what we need to do to figure out my n is I need to add up all of my factors, and this is what is going to be my final n. So I want to add up the exponent of 3 plus the exponent of 1 and the other exponent of 1, and we end up with 5. And we do end up with we end up 5 is not even, 5 is an odd. Now let's look at our leading coefficient. In this case, there's no leading coefficient. This is a 1 and a 1, so we would have done negative 4 times 1 times 1, which is negative 4. Let's go ahead and do it out, which is just negative 4. So we end up with a negative So now my end behavior is going to be up, comma, then down. So as my x approaches, how do I not know how to spell approaches? I already wrote it a bazillion times. Approaches, there we go. Negative infinity, my y goes to positive infinity. And then as my x approaches positive infinity, my y goes to negative infinity, and it'll look something like here. It's going to have a couple turns like that. 1, 2, 3. I think that's how many it has. So it looks something like that. That's just very, very rough, but you guys get the idea. So hopefully this clears up on how to figure out the end behaviors of our polynomials, and I will see you guys in the next